Hi everyone, it's Mr. Zarzik, and in this video I'm going to talk about pulleys. Okay, the first pulley I'm going to talk about what's called a single fixed pulley. A pulley is just a wheel with a rope that's somehow rolled around it. This pulley is fixed in place, so it's held in place at the top, so call it a fixed pulley. Right? It's got two 1 kilogram masses on each side. 1 kilogram, if you remember, weighs 10 newtons here on planet Earth, or roughly speaking. Okay, so that these forces are balanced. So I can just put this anywhere, okay, and these will stay at rest. This is also called an Atwood machine. That's not so much important, but if I just give it a little nudge here, okay, you can see that once I get it moving, it really doesn't take much. They kind of keep going by themselves, almost like once I set the object in motion, its natural tendency is to stay that way. Okay, so elevators use these to balance out the weight of the elevator, so that the motors that lift and lower people are really just worrying about the weight of the riders, not the elevator. Just so you can see, okay, all right, each of these weighs 10 newtons, so if I were to take off one of these masses, okay, and replace it with a spring scale here, okay, the force required to balance it's right about 10 newtons. Okay, so you can see if I just put this at rest, if I want to lift it, I have to pull it up with a force of right about 10 newtons to get it going. Okay? Okay, so next I'm going to show you what's called a single movable pulley. Single movable, there's one pulley, okay, and then when you raise or lower the mass, the pulley moves as well, up and down, so hence the name single movable. Now, I've got suspended here, I've got a 1 kilogram mass again, okay, which, if you remember, 1 kilogram weighs 10 newtons. So like if I have an equivalent little 1 kilogram mass, if I just hang it from a spring scale, we see that the spring scale reads about 10 newtons, and yet, using this pulley system, okay, we've only got to have a force of 5. Well, how does that work? Well, by running this string around the pulley, I've actually got two strands, two places where there's upward tension, so I literally divide up the weight between the two, so you half the force, all right? A pulley system is just a machine, okay, and machines all do the same thing. They trade force for displacement. So by reducing the force by a factor of 2, look what happens when I try to lift this mass upwards. So let me move this back just so that you can see, okay, up to the ceiling, right? And when we get on the ladder, you'll see why here in just a second. All right, if I take the mass, all right, if I start it down here, okay, on my little carts, all right, well, look at how far the mass moves up versus how far I have to move my spring scale. So I got to go all the way up here to the ceiling to get it to the top of the crossbar. Okay, so half the force means you're going to have to do the work over double the distance. Pretty neat. All right, next I'd like to show you what's called a single fixed, single movable pulley system. System because there's more than one pulley, okay, and single fixed, single movable because, well, when I start lifting these masses, one of these pulleys stays fixed in place, the other one starts moving around. The other thing that you should notice here is I got two different masses. I got a 1 kilogram and I got a ½ kilogram. Now, we've seen this a bunch of times, but 1 kilogram weighs about 10 newtons here on Earth, whereas the ½ kilogram weighs about 5 newtons here on Earth, okay, and so I'm able to balance 10 newtons with 5 newtons. I'm able to lift 10 newtons with only 5 newtons of force. In fact, if I take and replace the mass with the spring scale, you can see that I move my spring scale up and down, okay, with right about 5 newtons of force. Pretty neat. Now, of course, this is a machine, and machines all do the exact same thing, which is they trade force for displacement. So like, if I start these at the same location, look how far down I have to move the 5 newton weight versus how far up the 10 newton weight goes. Or equivalently, if I move this all the way up to the top, this only comes halfway to the down. All right, we trade force for displacement. Double the force, half the distance. All right, I can use this the other direction too, by the way. Okay, look, I barely moved the 10 newton, and look at how much the 5 newton moves around. But again, the cost of that is more force. So like if I attach my spring scale here, just so you guys can see this. All right, and I take off. Okay, well now look at this. It's showing 10 newtons of force. Okay, I got to lift this with 10 newtons of force, and yet I'm only lifting 5 newtons of weight. That's pretty neat. All right, remember, machines trade force for displacement. Okay, and back to equilibrium. Cool. Okay, so last but certainly not least, this is the 6-to-1 pulley. So this has 3 fixed pulleys and 3 movable pulleys. Okay, so you can see when I move the mass around here, so the 3 pulleys at the bottom move. Okay, the three at the top stay fixed. And there are 6 of these little 200-gram masses. This is 0.2 kilograms a pop, okay, being supported by one 200-gram or 0.2 kilogram mass. Now, just so you can see it, okay, I rigged up a little pan balance like you might see at the grocery store. Okay, so this is one of those little 0.2 kilogram masses, which weighs 2 newtons. So if I take and I stack 6 on here, so let's see, so here's number 2, number 3, 4, 5, and 6. Okay, so 0.2 kilograms a pop. If I have 6 of them, I'm going to get 12 total newtons. So think that 2 times 6 is 12. All right. So the point is I can hold up 12 newtons of weight with only 2 newtons of force. Now, that's not neat enough as it is. Okay, well, with the pulley systems, remember, these are just machines, so they trade force for distance. Okay, so like if I move this up and down, okay, these guys hardly move at all. Okay, I've got these 1, 2, 3, 4, 5, 6 strands of rope. So I got 6 tension forces supporting this. So I divide up the weight by 6, which is why only 2 newtons of force can lift 12 newtons. All right. Of course, there's always the trade-off. Okay, machines trade force for displacement. All right, and so I'm going to move this over here off to the side just so you can see this. All right, so just pay attention to how far this moves up when I pull this sideways, how much distance I have to cover with this mass. Okay, to get these things to move up just a little bit. All right, I'm not even at the top yet, but I'm running out of camera screen, so I'm just going to keep pulling. Pretty neat, but what it allows me to do is lift up something that's really, really heavy with a very small amount of force. All right, thanks for watching.